This lecture is going to focus on ways in which a researcher selects people or units to be included in a study. We call this sampling. In quantitative research methods, the sampling process occurs before any data are analyzed. The comic on this slide illustrates, in a humorous way, the challenges and importance of sampling. In the comic, Buck concludes that he had 100% satisfaction of his lemonade product. The humorous part of this is that he only had one participant in his sample doing the sampling of his lemonade. Generally, in quantitative methods, larger samples are desired. The reason for this is that a small sample can weaken the conclusions you can make about the relationship between variables in your study and limit the generalizability of your findings. In general, you want a sample that is sizable, as well as representative of your population of interest. Conversely, sample sizes in qualitative methods are generally smaller and can take place during data collection and analysis. Quantitative methods and qualitative methods have two very different approaches to sampling, but in this lecture we will focus on sampling techniques primarily used for quantitative research. In research studies, sampling refers to how the researcher selects participants for a study. Participants can include people, observations, or events. In general, there are two main categories of sampling approaches: non-probability and probability. Let's discuss non-probability sampling first. Non-probability sampling is an approach in which not all participants have the same chance of being included in the research study, and for each participant, the probability of them being included in the study is unknown. The other approach is called probability sampling. In probability sampling, all participants have the same known probability of being selected for a research study. It is also important to distinguish sampling from assignment. These are different terms that students sometimes get confused. Sampling refers to selection of participants. Assignment, which will be discussed in a different lecture, refers to what happens after the sampling, when a researcher decides how to assign participants from the sample into groups, such as a control versus treatment group. Again, sampling and assignment are different and generally occur at different stages of a research study. In addition, probability sampling techniques are generally considered more rigorous and therefore strengthen one's ability to make conclusions about the relationship between variables and make generalizations from the sample to the larger population. Non-probability sampling is considered less rigorous than probability sampling, and as a result increases the error in conclusions one can make about the relationship between variables and generalizability. Within the non-probability approach, there are 4 types of specific sampling techniques. Within the probability approach, there are also 4 types of specific sampling techniques. We will now take a look at the specific non-probability and probability sampling approaches. Let's examine these sampling techniques through an example research study scenario. When I was a school social worker in Southwest Houston, Baylor College of Medicine was conducting research on childhood obesity. Let's imagine, for example, that Baylor was interested in conducting a childhood obesity study with kids in the Gulfton area in Southwest Houston. Here you see the general Gulfton area boundary in Southwest Houston. Let's look at various sampling techniques using this research study example. Remember, the non-probability sampling approach includes 4 main sampling techniques. The first is called purposive sampling. In purposive sampling, the researcher uses their own judgment to select participants with specific characteristics. With this technique, there is nothing random about how participants are being selected. Let's look at an example within our Baylor study. In purposive sampling, the sample is usually based on the researcher's judgment and objective of the study. If the Baylor researchers were interested in selecting a sample of kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize purposive sampling, Baylor researchers might work with the school nurses to select kids for inclusion. For example, the school nurses might have BMIs or body mass indexes for each student based on fitness testing records. Baylor may then select those kids who have BMIs greater than 30% for inclusion in their study. Since a BMI of 30% or greater is indicative of obesity, Baylor might use this criteria to purposefully select these students for their study. The second non-probability sampling method is called availability or convenience sampling. In availability or convenience sampling, the researcher selects participants who are most easily available. With this technique, there is nothing random about how participants are selected. Let's look at an example within our Baylor study. In availability sampling, the sample is usually based on who is most convenient to the researcher. If the Baylor researchers were interested in selecting a sample of kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize the availability sampling, Baylor researchers might stand outside of Guitton area middle schools during dismissal and pass out recruitment flyers for participation in their research. The kids would take these forms home to share with their parents or guardian. This technique wouldn't necessarily be based on who was obese and who wasn't. It would simply be based on inviting those kids to participate who were most readily convenient to the researcher. The third non-probability sampling method is called snowball sampling. In snowball sampling, the researcher asks current participants if they know of anyone else who might want to participate in their study. With this technique, there is nothing random about how participants are selected. Let's look at an example within our Baylor study. In snowball sampling, the sample is usually based on leads that participants can provide to the researcher regarding other people they might know who might want to participate. If the Baylor researchers were interested in selecting a sample of kids in the childhood obesity study in the Guitton area of Houston and wanted to utilize snowball sampling, Baylor researchers might ask each of their current participants, "Do you have any friends who might want to participate?" If a participant answers yes, then the researcher might give that kid a recruitment flyer to give to their friend. The researcher may even be specific in asking about leads with certain characteristics. For example, the researcher might ask the participant, "Do you have any friends that are aged 10 to 13 who might want to learn about healthy eating?" If the participant says yes, the researcher may give that participant information for participation in the study to give to their friend. The fourth non-probability sampling method is called quota sampling. In quota sampling, the researcher identifies relevant characteristics of a desired sample, and participants are selected until the quota of characteristics is obtained. With this technique, there is nothing random about how participants are selected. Let's look at an example with our Baylor study. In quota sampling, the sample is usually based on the demographic categories of desired participants and the number of participants the researcher would like to obtain. If the Baylor researchers were interested in selecting a sample of kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize quota sampling, Baylor researchers might want to obtain a sample of youth for their study, which accurately reflects the developmental stage of childhood. Therefore, Baylor researchers might decide they need around 150 participants and would like equal proportions of participants that represent the 3 levels of schooling: elementary, middle, and high. Therefore, Baylor may begin sampling across schools in the Guitton area, and when they reach 50 participants in their sample from elementary schools, they will stop sampling from elementary schools once the number of participants is equal to 50. They would do the same with the middle school and high school so that there are 50 participants from elementary, 50 from middle schools, and 50 participants from high schools to be included in the study. Once Baylor has reached the number of participants from each school, they will stop sampling. Here, they have set a quota of 50 participants per school type. Remember, the probability sampling approach includes 4 main sampling techniques as well, and are considered more rigorous and systematic than non-probability sampling we just finished reviewing. Probability sampling approaches help to ensure that the sample obtained most accurately reflects the population from which the selection was obtained. This helps to make the argument that your findings are generalizable from the sample to the larger population. The first probability sampling approach is called simple random sampling. In simple random sampling, members of a population are selected at one time without the chance of being selected again until the desired sample size is obtained. Let's look at an example within our Baylor study. In simple random sampling, the sample is based on random selection of participants. Once a person is randomly selected, he or she does not go back into the pool of potential selectees. If the Baylor researchers were interested in selecting a sample of 20 kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize simple random sampling, Baylor researchers might go to a school in the Guitton area and work with the front office staff to assign a number to all students in the school. Imagine in this school there were 100 students. The Baylor researchers will then put the number into a hat and start drawing the numbers one at a time. Once a number is drawn, it does not go back into the hat. The researcher keeps drawing randomly until 10 students have been selected. Until 20 students have been selected. Those who were randomly selected would be selected to participate in the research study. The second probability sampling approach is called systematic random sampling. In systematic random sampling, members of a population are selected at designated intervals without the chance of being selected again until the desired sample size is obtained. Let's look at an example within our Baylor study. In systematic random sampling, the sample is based on random selection of participants at a specific interval. Once a person is randomly selected, he or she doesn't go back into the pool of potential selectees. If the Baylor researchers were interested in selecting a sample of 10 kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize systematic random sampling, Baylor researchers might go to a school in the Guitton area and work with the front office staff to assign a number to all students in the school. Imagine in this school there were 100 students. If the researcher needs 10 participants and there are 100 kids in the school, the researcher would sample every 10th person, for example. Using this technique, they might select person number 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Those who were randomly sampled at every nth interval would be selected to participate in the research study. Now things really begin to get complicated with these last two approaches to probability sampling. The third probability sampling approach is called stratified random sampling. In stratified random sampling, members of a population are selected based on two or more strata or criteria sampled separately and randomly. Let's look at an example within our Baylor study. In stratified random sampling, the sample is based on random selection in strata. If the Baylor researchers were interested in selecting a sample of 10 kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize systematic random sampling, Baylor researchers might first take a look at the demographic makeup of the Guitton area. For example, the demographic makeup of youth in the Guitton area might be 60% female and 40% male. The demographic makeup might also be 80% Hispanic, 15% African American, and 5% Anglo. If Baylor wanted to select 10 student participants from a high school in Guitton, they would randomly select students that most closely represent the proportions for gender and ethnicity in Guitton. This systematic approach will help obtain a sample that most accurately reflects the general youth population makeup in Guitton. Therefore, in a school of 100, if Baylor needed 10 participants, the researcher would randomly select students in the first strata, gender, until 6 were female and 4 were male, and the second strata, ethnicity, so that of the 10 participants, 8 were Hispanic and 2 were Anglo. Note that sometimes the strata are proportional, sometimes they are not. Consider our strata on ethnicity being 15% Hispanic. There is no way to get 1.5 participants that are Hispanic, since one can't only include half a person. Therefore, the researcher would make a determination how to base inclusion for ethnic status. Cluster random sampling is the fourth and final approach to probability sampling. In cluster random sampling, members of a population are not divided into individuals. Instead, the population is divided, or the sample is divided into larger groups or clusters, and those clusters, rather than individuals, are selected for inclusion in a sample. Let's look at this last example within our Baylor study. In cluster random sampling, the sample is based on clusters. If the Baylor researchers were interested in selecting a sample of 100 kids in their childhood obesity study in the Guitton area of Houston and wanted to utilize cluster random sampling, Baylor researchers might first find the names of each school in HISD. Let's say there were 200 schools. Baylor might then write the name of each school onto a piece of paper and put each paper into a hat. And he or she decides to randomly choose 20 schools. Each school represents a cluster. Baylor then would randomly select 20 schools from the hat. The reason Baylor might first select clusters is that there might be a stark differences between schools in HISD in terms of student makeup, demographics, economics, ethnicity, neighborhood resources, and challenges, etc. And randomly selecting clusters based on schools might ensure the sample best reflects the district as a whole. After the 20 schools or clusters are selected randomly, then Baylor will select every student at all 20 schools for participation in the study, perhaps by sending home information about the study to all of those students, which the school administrators might distribute in a way that logically fits in with each individual school's operation. The cluster sampling technique is sometimes more cost and time efficient, when in this case the researcher might not be able to select individual students to participate, but still want some kind of random selection so the sample can more accurately reflect the diverse population in HISD. Remember, there are pros and cons for both probability and non-probability sampling approaches. How do you choose the right one for your study? This all depends on several considerations. Is your study using quantitative methods or qualitative methods? What's your desired sample size? Which technique will strengthen the conclusions you can make about relationships between variables and generalizability of your findings? What is the most feasible based on the time you have, the culture of the population of interest, logistical considerations, etc.? Choosing a sampling technique requires a lot of forethought and planning so that you can utilize the technique that is most appropriate for your research study. This concludes the lecture on sampling theory and techniques. Please stop by my office or email with any questions.